Okay, this is the review for the graphing trigonometric functions and applications test for Thursday, January the 19th, 2017. All right, so the first question says, what are the amplitude, phase shift, and B in the given function? All right, so first of all, we simply need to look right here for the amplitude. So amplitude is 1/3. Remember, amplitude is always positive. Amplitude is always positive. All right, the next thing I'm going to look at is the value for B. B is right here. Okay, in this case, B is not factored out yet, but it's still the same value, so B is 2. So that just leaves us with the phase shift. So to calculate the phase shift, we have to take this value right here, and we need to factor out the B, and we need to change the sign. So if we factor out a B, that means we're dividing by B. So if I take 2 pi and I divide by B, I get pi. And if I change the sign, I get negative pi. That means my graph is moving to the left, negative pi radians. So my phase shift is negative pi. All right, number 2, a water wave is created in a wave tank. It has an amplitude of 6 inches and a period of 3 pi. Find the equation of this wave as a sine function. All right, so first of all, the amplitude is 6. So we're just going to write our 6. Then we write our function sine. And now the period is 3 pi. So it looks like we might have a B value since B changes the period. So we would take 2 pi over B, 2 pi being the normal period for the parent function, and we ended up with 3 pi. So what you have to do here is solve for B, and then we know what B is. Well, if you cross multiply and solve for B, you will find that B is 2/3. So you can put a parentheses or you don't have to in this case, but I'm going to go ahead and do it. 2/3 theta. Okay, and there's our sine function. You could also put an x in where theta is. It doesn't matter for this test. I'm going to go ahead and use theta. So my equation is going to be y equals 6 sine of 2/3 theta. Number 3, what is the reciprocal function of sine, cosine, and tangent? The reciprocal of sine, or 1 over sine, is cosecant. Okay, the reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. 1 over tangent is cotangent. All right, so you just need to know those reciprocals for the test. All right, so in questions 4 and 5, we're going to use this graph right here, use the following graph for questions 4 and 5. First thing you want to look at when you're looking at your graph, this is not the same graph that's going to be on your test, but it's similar. The first thing that you want to look at when you're analyzing your graph is look at you want to look here at the horizontal axis to see what your period is. Okay, in this case, our graph goes from 0 to pi. So that appears to be the period for our graph. If you follow this period or this one cycle of this wave, it stops at pi. All right, so then our period is going to be pi. All right, so first of all, that's what we're going to write here in our blank. The period is pi. Then we need to determine B. Since the period is not 2 pi, the period is pi, we need to figure out what B is. Well, we know that 2 pi over B equals pi, because that's our new period. All right, so what would B have to be? Well, B would have to be 2. If I cross multiply this and cancel out my pi's, I would get B equals 2. So in this case, B is 2, so we have a compression, horizontal compression. The amplitude for this, well, we would have to go ahead and divide your graph in half, okay? And this line right here would tell us how far up or how far down we need to go for our amplitude. Our amplitude in this case is going to be 1. Vertical slide. Now the vertical slide just means the vertical shift up or down. Okay, slide is shift, the same thing. Okay, vertical shift. So I have to count from the original axis down here, how far up did we shift this? Well, 1, 2, 3, 4. We shifted it up 4. So plus 4. All right, now we need to look at phase shift. Well, that depends on where we start. If I'm writing an equation for this graph, that's a sine wave. And if I start my sine wave right here at the center, I'm starting on the y-axis. If I start my wave on the y-axis, then there's no phase shift. There's only a phase shift if I'm starting other than on the y-axis. So when you can, start on the y-axis. So in this case, I'm going to start on the y-axis, and this is going to be a sine wave. So for sine, in this case, I have none for phase shift. For cosine is going to be different. For cosine, all the values up to this point are the same as for sine. The period's 2 pi, B is 2, amplitude's 1, the vertical slide is 4. So the phase shift is the only difference between sine and cosine. And that depends on where you start. You have to pick a spot. And where you pick the spot will determine what your phase shift is. So not everybody's going to pick the same spot. So I don't want to see everybody having the same thing on their test answers. So you need to pick a spot. I'm going to pick this spot just because. And then the cosine wave is going to come down and then back up again. All right? So that's my cosine wave. So the red one is my sine wave. The blue one is my cosine wave, and now I'm ready to write my equations. Now the cosine wave has a phase shift. It looks at as if it is negative pi over 4. If I break up my horizontal axis into fractions, between 0 and negative pi over 2 is negative pi over 4. So I have a phase shift for my cosine wave of negative pi over 4. So we're going to say negative pi over 4 for the phase shift for cosine. So now I'm ready to write my two equations. Okay, so I'm going to write the sine right here. Now the sine wave, if you'll notice, the sine wave goes down first. If the sine wave goes down first and then up, that means that I have a reflection. So I have to make sure that if I have a reflection in the wave that I chose, that I put my negative sign in front of sine. All right, so I'm going to need to do that. So let's go back to where I'm going to write my equation. I'm going to make it negative sine. And my b is 2, and I'm going to leave that outside the parentheses. And the reason I'm doing that is so that I don't have to do anything special with, well, this one doesn't have a phase shift anyway, so just, it doesn't matter really how you write it. You can write it negative sine 2 pi in parentheses, theta in parentheses, or you can write it without parentheses. It doesn't matter. All right, so for cosine, the period is the same, b is the same, amplitude is the same, vertical slide is the same, except what's different now is I have a phase shift of negative pi over 4. I'm moving to the left, pi over 4. So how I'm going to write that equation is like this. In my cosine wave, I don't have a reflection. It starts up here at the top, and it goes down first and then up first, and that's what cosine is supposed to do. Okay, so cosine starts on the y-axis usually, but this time we have a phase shift. So it's actually starting here, and then it goes down and up and back up again. Okay, so this one is not a reflection. Okay, so I'm going to say that this is, and their amplitude is 1, so all I need to write is the word cosine, or the function description cos. All right, so then my b is 2, and I'm going to keep it outside the parentheses, separate from my phase shift. And then I'm going to write my theta, and now I've got to change the sign of my phase shift. Don't forget to change the sign right here, because remember, when we put the sign inside the parentheses, it's minus a negative. In this case, we have a negative direction, so we have to put in a positive sign. So we're going to write plus pi over 4 plus 4. Okay, so don't forget your plus 4. Oh, up here for the sine wave, I forgot my plus 4, sorry. Plus 4. Okay, yeah, it's supposed to have a plus 4. Sorry about that. It's negative sine 2 theta plus 4. Now with cosine, it's 2 theta plus pi over 4 for the phase shift plus 4, and that needs to be in parentheses. Another way I could have written this, it's a little more work, but you could have written it this way. Cosine, you could have put the 2 inside the parentheses with the theta, but if you do that, you have to multiply. You're going to have to multiply this 2 also times this pi over 4, okay, which would give us then, it would not be pi over 4 anymore, it would be pi over 2. So you could have written it like that as well. Either one of those is correct. So remember, your equation depends on where you start your wave on the graph. Not everybody's going to start in the same place, and that's okay. Pick a place that you think is probably the easiest spot to write an equation, and normally that's probably going to be on an axis. If you can find a spot on the axis, like I started here on the y-axis, that's usually an easier equation to write because there's no phase shift. Or a spot close to the axis, because then your phase shift isn't so large. All right, so just a little bit of pointers there, and I could have started my my cosine wave down here, then it would have been negative. So just whatever point you start, you need to make sure that you mark that point so that I know where you started your wave. At least draw in or highlight which wave that you're writing your equation for. All right, so moving on to question 6. This says make a table. All you have to do for this one is make the table. That's all you have to do. So you're going to have to know how to read your equation. A cotangent B theta minus C over B plus D. Okay, so you need to know what you're looking for here, and you need to remember what does what to what. All right, so on our graph, when we're graphing, this is our theta, and this is our cotangent. Okay, so anything that changes the value along this theta axis, the horizontal axis, is going to come from the inside of your equation. So those things are going to change your theta values or your radians. The ones on the outside, A and D, are the values that are going to change your function values, your cotangent of theta. That's what's going to change the cotangent of theta. All right, so given that, I'm going to look at my equation here, and I see that I have one, but only one change right here to theta, and it's a B change. And you need to remember to multiply theta by the reciprocal of B. So we're doing the opposite operation. So I need to multiply theta by 2. Okay, so 2 times 0 is 0. 2 times pi over 4 is pi over 2. 2 times pi over 2 is pi. 2 times 3 pi over 4 is pi 3 pi over 2, and then 2 times pi is 2 pi. Okay, so these are my new theta values with this stretch we have. All right, now I'm going to look at the cotangent of theta values. Okay, so you're given the cotangent of theta values, and now you have to apply to those values, you have to apply your A and D changes. Here we have an A of -2, and we have a D of -2. So you're multiplying by -2, and then you're subtracting 2. Well, undefined is just undefined. That's where your asymptote is, so you're not going to do anything with that. But here with 1, I'm going to multiply by -2, I'm going to get -2, and then I'm going to subtract 2, I'm going to get -4. Then the 0. 0 times -2 is 0, minus 2, -2. -1 times -2 is 2, 2 minus 2 is 0, and then undefined. And that's all you have to do. You just need to create the table for number 6. Just the table. That's all you have to do. All right, question number 7 is the one that packs the most punch. So number 7 is the one that you really know, really have to know what you're doing. You have to create a table and a graph for number 7, and you have to write a paragraph about it. So number 7 is a very important question. Make sure you know how to do number 7. Okay, so the first thing you want to do before you start creating your table is looking to see what kind of changes you're going to have to theta and to cosine of theta. So just remember that the insiders change theta. So if you have a B value or a C value, this would be a C over B, a phase shift. If you have those are going to change theta. So we actually have 2 changes to theta going on here. So I'm going to make 2 columns for theta. Theta, the original value, and then the 2 changes. For cosine theta, I also have 2 value changes. Those are going to be A and D. My A change and my D change, those are going to change the cosine. So I also need 2 columns here. All right, so let's start with what theta should be. So theta should be, for the parent function, is 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are the main points that we're using on the unit circle to graph cosine. All right, those are the angle measurements. All right, so then we have some changes to theta. First of all, we need to look right here, and we see right here that there is a value of 2 for B. So that means that I need to multiply something times theta. Well, if you remember, you have to do the opposite operation for these insiders, okay? So since I'm multiplying by 2, I actually need to either multiply by 1/2 or I need to divide by 2. So I'm going to take my theta and I'm going to multiply times 1/2. Okay, I'm multiplying by the reciprocal of B. So 0 times 1/2 is 0. Pi over 2 times 1/2 is pi over 4. Pi times 1/2 is pi over 2. 3 pi over 2 times 1/2 is 3 pi over 4. And then 2 pi times 1/2 is just pi. All right, now we need to take care of the phase shift. Now, since this value for B has already been factored out, then this value right here, this pi value, is actually C over B, all right? So we already have our phase shift here, so we don't have to do any special math or anything to get the phase shift. All we have to do is change the sign. So we're going to subtract a pi from all of our new angle measurements. So let's go in and do that. Minus pi. So 0 minus pi is negative pi. Pi over 4 minus a pi is going to give me a negative 3 pi over 4. Pi over 2 minus a pi is a negative pi over 2. 3 pi over 4 minus pi is is a negative pi over 4. And then pi minus pi is 0. All right, so we're on the left side of the graph now with all of these negative angles. Then we're going to do the cosine. The cosine of theta is at 0, theta is 1. Cosine of theta is 1. At pi over 2, it's 0, then negative 1, then 0, then 1. Those are the values for cosine on the unit circle. Now I'm going to do my a change. My a change is 1/2. So again, I'm going to multiply by 1/2. No tricky math here, just multiply by what it is. So 1 times 1/2 is 1/2. 0 times 1/2 is 0. Negative 1 times 1/2 is negative 1/2. 0 times 1 is negative, or 0 times 1/2 is 0. 1 times 1/2 is 1/2. Now I'm going to do d. The value for d is plus 1. So I'm going to add 1 to all of those. So 1/2 plus 1, 3 over 2, or 1.5. This would be 1. This is going to be 1/2. This one is going to be 1 again. And then 1/2 plus 1 is 3 over 2, or 1.5. I'm going to just stick with a fraction. It's a little bit easier to keep track that way. All right, so what are we supposed to graph? Well, the last change we made to our angle was this one. So we're going to graph the last change we made to the angle and the last change we made to the function. These are what we're going to graph. This is going to be what's on the horizontal axis, okay? And this is what's going to be on the vertical axis. So if you want to think of it as x and y, this would be this one over here would be your x, and this would be your y if you want to look at it that way, okay? So this is your angle measurement, and this is going to be your value up or down. All right, now if I look at my graph, I can see that my graph goes from 0 to 2 pi, from 0 to 2 pi. And my angle measurements here, though, are in quarters. So I am going to have to go back over on this side of the graph where I'm going to be graphing, and I'm probably going to need to add in those quarters. So I'm going to go ahead and do that. So you can add in your values that you don't have if you need to. Okay, so that one's negative pi over 4. This one's negative 3 pi over 4. Okay, so that's going to help me when I get ready to graph, since I'm going to be graphing between 0 and negative pi. So I need to make sure that I am able to graph there. All right, and I have all the points and all the graph angles I need on my horizontal axis. All right, so let's start graphing. All right, up here we have a negative pi. At negative pi, we need to go up 3 halves, or 1.5. So I'm gonna graph this in red, I think. Okay, at negative pi, I need to go up 3 halves, which should be right here. Then I need to, for negative 3 pi over 4, which would be my next spot, I need to go up 1. So that would be right here. Then at negative pi over 2, my next angle, negative pi over 2 is my next angle, I need to go up 1/2. All right, then my next angle is negative pi over 4. I'm going to go up 1. And then at 0, I'm going to go up, again, 1.5, or 3 halves. And this right here is my cosine wave. Here it is. Okay, there's my cosine wave. And that's really all you need to graph. You could keep continuing to graph the wave if you wanted to on both sides, but I'm going to be looking for this right here on the test. Okay, I'm going to be looking for the wave that's created by this angle and this function. So make sure that you get those points in. If I don't see those points on the graph and you just copied this off your calculator, you're going to lose about half the points on your graph. So please make sure that you're getting those points in. They're very important. Okay, let's go to the next page. This is problem number 8. And in problem number 8, you're given a graph, not this exact graph, but a graph similar to this. And you have to determine the period of the graph and all of the information, the B, the amplitude, vertical slide, the phase shift, and then you have to write 2 equations. You have to write a sine equation and a cosine equation. And if you remember from earlier, I said the only difference between the sine equation and the cosine equation is going to be that phase shift. So it depends on what your phase shift is. All right, so let's just start with period. How do you read the graph? Well, you come up here to the graph and you look to see, it's sometimes easier to read peak to peak. So if I'm reading peak to peak, then if I select this point right here and I go down and I come back up and I go back here and I stop, that would be 1 period. So in this case, on this graph, the way it's scaled, 1 period is pi. So I would write pi in right here for period. Okay, so remember, period for sine and cosine is the same. So the period's going to be the same. The B is also going to be the same. So what I need to do is I need to calculate what the B is. Well, I know that 2 pi is my normal period for cosine or sine. And 2 pi over B gives me my period. So if my period is pi, then my B must equal 2. So B is 2, and B is 2 for sine and cosine. Then I need to look at the amplitude. The amplitude, as you know, is how far up from the center, this is the center line, how far up and how far down the graph goes from the center. That is your amplitude. So if I start at the center and I count up 1, 2, 3, 4, 5, then my amplitude is 5. And the amplitude is going to be the same for sine and cosine. Okay, vertical slide. Well, in this particular graph, my graph is on my center line of my graph is on the axis. So if the center line of my graph is on the axis, then I don't have a slide or a shift up or down. Okay, slide is the same thing as shift. I don't have one, so I would just put none in this case. The one on your test might have a shift. You need to count and see. Okay? Phase shift. So a phase shift depends on if I pick sine or cosine. All right? If I'm doing a cosine equation and I'm using this point that's located right here on the y-axis as my starting point, then I don't have a phase shift because I'm starting on the y-axis. But for the other function, for sine, I'm going to have to start at some other point that's not on the y-axis. So I'm going to have a phase shift for sine. So it depends on where you start. For sine, you can start anywhere you want on the x-axis. Anywhere you want, okay? So you can start here, you can start here, you can start here. It doesn't matter as long as you tell me where you're starting and you mark on the graph where it is you're starting. A good rule of thumb is to start close to the axis, the y-axis as possible, but it doesn't really matter where you start. You just need to know what your phase shift is. Okay, so if I wanted to start my sine wave right here, do a different color, right here, I could start it right here, but I need to figure out where that is on my horizontal axis. Okay, so let's go ahead and write the cosine wave since that's the easy one and we don't have any phase shift. This one's going to be positive cosine. Our amplitude is 5, so we need a 5 in front of that. And then we have a B value of 2, so 2, and then the parenthesis. There's no phase shift, so I'm going to close the parenthesis there. And there's no vertical slide or vertical shift. So that would be it. That would be my equation for cosine. And I could put a y equals in front of that, or f of theta if I wanted to. All right, so sine equation. Now this one's going to be a little more difficult, depends on where we start. If I start my sine wave right here, I need to figure out, and this would be a positive sine wave because I'm going up first, I would need to figure out how far away from the y-axis did I go. So, in this case, I need to divide up my horizontal axis. This is negative pi. This is negative pi over 2 if I cut it in half. If I cut that in half again, then this is negative pi over 4. So that means that I shifted to the left pi over 4. So I have a phase shift for cosine, I'm going to do it in blue, of negative pi over 4. For sine, sorry. Okay? So for sine, I have a phase shift of negative pi over 4. So when I'm writing my sine equation, my sine is positive. I have an amplitude of 5, so I'm going to write 5 sine. I'm going to put my 2 in for my b value. I'm going to keep it outside the parentheses, so I'm writing the simplest equation I can. I'm going to put in my theta, and now for the phase shift, I have to change the sign to positive. So I'm going to change it to positive. And there's no vertical shift, so then I'm done. So the sine equation is 5 sine 2, and in parentheses, theta plus the phase shift, close parentheses. Now, I could have written that like this. I could have written it like this with the 2 inside the parentheses, but then I would have had to multiply my phase shift by 2, and that would have given me a pi over 2 here inside. So it does matter. You need to be careful about whether you're keeping the 2 inside or outside the parentheses. All right, last thing on the test is going to be a paragraph that you're going to have to write. This needs to be a complete paragraph in your words describing how you determined the table and graph for the function in number 7. And you need to make sure that you use complete sentences, and you're going to write your answer underneath the description for question 9. So make sure that you think about that tonight before your test tomorrow, and make sure you kind of have an idea of how you're going to describe how you created your table and how you created your graph for number 7. And that's it.